The next section of parametric equations, we're going to get into applications. And for the applications, we're going to need to look at a little bit of physics and how objects move through air and how gravity interacts with them. So going back to what we talked about in the first section, we talked about a football being punted. And we said that y equals negative x squared over 72 plus x is going to give me the path a football travels. And if you plug that into your calculator, you could see that the graph looks something like that. That's realistically what a football does. A couple things we want to add to this. First of all, this equation right here, this negative x squared over 72 plus x, that indicates the equation specifically when the football is kicked at a 45-degree angle. So we've got a very specific angle there. And it's traveling at 48 feet per second starting from the ground. So those are two little requirements that we have. And I just threw out to you that when we write this in parametric form, it ends up being x equals 24 square root of 2t and y equals negative 16 t squared plus 24 square root of 2t. You're probably wondering, well, how do you get the square root of 2 from this equation, or the 24 or the 16? They're nowhere to be found. And that's where we've got to start looking at how an object moves through the air with horizontal components and vertical components. And when you look at an object moving through an air, you can look at it in terms of vectors, x vectors and y vectors, every single point along this path. And the resultant vector is the direction that the object is moving. So what you would need to know from physics is that there are two relationships. One is the x relationship and one is the y relationship. And we got into this a little bit with our tension problems. We said that gravity is only affected in the vertical direction, which is why in our tension problems we only dealt with the weight in the vertical direction. The horizontal always canceled out. Same idea is going to apply here, that when we're talking about gravity, it's only going to affect the y portion of the parametric equation. So here's the relationships that we come up with. The first relationship is the x relationship. And the physics behind the equations is that the x relationship is equal to v sub 0 times the cosine of theta times t. Now your v sub 0 right there, in this case, is going to be my initial velocity, which I'm saying is 48 feet per second. And I'm telling you that the angle is at a 45-degree angle. So if I plug in my initial velocity, which is going to be 48, I know the cosine of theta, we're at a 45-degree angle, so the cosine of 45, and then times t. Well, we know the cosine of 45 is square root of 2 over 2. And here I can then cancel square root of 2 over 2. That can cancel down the two pieces right there to being x equals 24 square root of 2t. So that's where we get the x component. The y component's a little bit more complicated. The y piece for the parametric equation is negative 1/2 gt squared. That's the first piece. Then we get v sub 0 times the sine of theta times t plus the height. That should be multiplication there, sine of theta times t. G is the acceleration due to gravity, which the acceleration due to gravity is 32 feet per second. So since we're talking about feet here, We'll plug in our 32 feet per second. I know my initial velocity once again is 48, and then the sine of theta is the sine of 45, and my initial height is 0 since I'm kicking it off the ground. So here this turns into negative 16 t squared plus 48. The sine of 45 once again is square root of 2 over 2 times t. And then once again, I've got my square root of 2 over 2. The 2 cancels with the 48 to give me 24 square root of 2. So in terms of the physics, right here, that equation and this equation would always be given to you. This is not a physics class, so I don't expect you to memorize that. But knowing what the pieces are and reading it out of a story problem is going to be key. So now what we want to do is we want to move on to our first example on the top of page 139. And on the top of 139, we're dealing with a ring toss. So basically, the problem that we're looking at is Sam is standing back from the ring toss game, and here are his ring pegs. And he's throwing the ring onto the pegs. So let's look at our situation here. Each year, Sam looks forward to the ring toss at the county fair. Not happy to hit any peg, but pride himself in hitting the middle peg on the front row each year. That's great. We know he's got a horizontal velocity of 8 feet per second and an initial vertical velocity of 3 feet per second, and that he'll release the ring when it is 4 feet above the ground. Sam lines up directly in front of the middle ring and is 4 feet away from the platform. So we want to know what is the setup for this ring toss. And we also have right here that there's a short stool that measures 1 foot in height. The pegs are 2 inches in height, and the bottom of the first row is 4 inches from the bottom of the game. So we've got a lot of information that we've got to digest right there. So let's start by writing these in parametric form. So the first piece that we have is we've got the vertical position and the horizontal position. So if we go back to our equations, x equals v sub 0 cosine of theta times t. That's going to give me the horizontal piece. Now it tells you right here the horizontal velocity of 8 feet per second. And since we're specifically talking about the horizontal velocity, that means we've got no angle measurement. So here, my 8 feet per second, I'm going to have the cosine of 0, because I'm just talking about straight horizontal. We know the cosine of 0 is 1. So here, x is going to be 8t. The other piece that we've got then is the vertical position. And we know the vertical position is given by the equation negative 1/2 gt squared plus v0 sine of theta times t plus my initial height. And we know the g is going to be 32 feet per second since we're all in feet. And so this will be negative 16t squared for the first part. I plugged in 32. Half of 32 is going to be 16. We're given that the initial vertical velocity of 3 feet per second. So if I'm going to be going 3 feet per second and I'm going strictly vertical, it's the sine of 90 degrees. Plus I'm given that we've got the height of 4 feet total. So we're looking at an initial release of 4. That comes from right here. He'll release the ring when it is 4 feet above the ground. So we know sine of 90 is 1. So this equation just simplifies down to negative 16 t squared plus 3t plus 4. So my two equations that I'm working with are x equals 8t and y equals negative 16t squared plus 3t plus 4.